Hey everyone. In this video, we're going to be talking about hydrocarbons. So hydrocarbons, as the name would imply, are things that are composed of hydrogen and carbon. So organic molecules that only have carbon and hydrogen atoms. Now we can break this up into four subcategories of hydrocarbons. And so we've got alkanes, alkenes, alkynes, and aromatic compounds. Now, alkanes have only carbon-carbon single bonds. Alkenes have one or more carbon-carbon double bonds, and alkynes have at least one carbon-carbon triple bond. Now, aromatics have a six-membered ring, kind of like a hexagon, and then it's got some double bonds in there. We'll take a look at that more specifically here in a minute. So here's a chart showing the four types of hydrocarbons. General structure, here's an example of each. Here's the ball and stick model for each. And then the functional group is something that we'll talk about in upcoming chapters. But a functional group is the important part of a molecule. It's the group of atoms in a molecule that are functional. And so the alkene, it's the carbon-carbon double bond. The alkyne, it's the triple bond. And in the aromatic ring, it's the ring itself. So let's look at another way to differentiate hydrocarbons. So separate from the four categories we just talked about, you can classify hydrocarbons as either saturated or unsaturated. Now, saturated hydrocarbons have only single bonds. That means that every carbon is bonded to the maximum number of hydrogens possible. So this molecule here can't fit any more hydrogens. Every carbon is already bonded to the maximum amount of hydrogens possible. Now, an unsaturated hydrocarbon has either a double or a triple bond somewhere in the structure. And we call it unsaturated because the molecule doesn't have the maximum amount of hydrogens. In fact, unsaturated hydrocarbons can react with hydrogen gas and absorb more hydrogen atoms. So they are said to be unsaturated with hydrogen. So the formula here for the saturated one would be C3H8. And for the unsaturated one here, it's C3H4. And so you can see there's fewer hydrogens because it's unsaturated. So let's go back and we're going to look at each of these subcategories in a little more detail. So alkanes are molecules composed of carbon and hydrogen with only single bonds. Every atom is surrounded by four groups, so it's therefore tetrahedral, has a bond angle of 109 degrees. So here is a simple alkane drawn in expanded form. But if we were to look at it in a ball and stick model, you would see that it's three-dimensional. It's tetrahedral. The bond angles are 109 degrees. And so if we were to do this with wedge and dash, this would be coming towards you. This one is coming towards us. And this one is going away from us. This one is going away from us. So it's three-dimensional. Now, the simplest alkane is known as methane. It's just CH4, single carbon. It's a really powerful greenhouse gas, and it's the main component of natural gas that we get from the petroleum industry. So when they drill for oil, methane naturally boils up, and usually they actually have a flame burning the excess methane that just comes up out of the ground. That way it doesn't build up and explode possibly. So they just burn it as it comes out of the ground because there's so much of it. But the excess, they pipe into your homes as natural gas. So you run your stove basically on methane gas. That's the #1 use for methane. All right, let's take a look at alkenes. So alkenes have at least one carbon-carbon double bond. So if a carbon has a double bond, that means that it only has 3 groups attached. And so it's therefore trigonal planar shaped. So the bond angles are 120 degrees. So this molecule here is flat. Nothing's coming towards you, nothing's going away from you. This is flat molecule, 120-degree angles, trigonal planar. Now, a specific example is ethene. This is the simplest alkene. It's just 2 carbons double bonded to each other. It's also commonly known as ethylene. It's actually a plant hormone. So plants release ethylene, and it triggers the rest of the plant to ripen. So we pick fruit, particularly bananas, green, totally unripe, and then we ship them in boats across the ocean to get to their destination. And then once they're at their final destination, we lock them in sealed warehouses and we pump ethylene gas into the warehouse, and the bananas artificially ripen on site, and then they put them out on the store shelves. So we can trigger fruits to ripen by using ethylene gas, which is kind of cool. Because if we didn't do that, there'd be no way to get bananas halfway around the world because they'd rot by the time you ship them there. So this allows us to pick fruits unripe and then ripen them when the time is appropriate. It's also the hormone responsible for like flowers wilting and leaves falling off of trees. It's a similar process. Let's take a look at alkynes. So an alkyne with a Y has at least one carbon-carbon triple bond. So if a carbon has a triple bond, that means it only has 2 groups attached, which gives it a linear shape, and the bond angles are 180 degrees. So this molecule here is flat. It's in a straight line. It's linear. The bond angle here is 180 degrees. Now, the simplest alkyne is ethine, drawn here. It's just 2 carbons with a triple bond. It's commonly known as acetylene. And so we use this in acetylene welding torches. So when this burns, it burns extremely hot because the triple bond gives off a lot of energy. And so we use this gas to run welding torches so that they're hot enough to cut through metal. So, kind of cool. And the last category are aromatic compounds. Now, the term aromatic comes from like 1700s. They were studying compounds that had an aroma to them, like fragrances that they would use in perfume. And they later determined that a lot of those fragrances had this type of structure as part of the molecule. And so the name stuck as aromatic compounds. But not everything that has this structure actually has an aroma. It's just the name stuck historically. So aromatic compounds have a ring of 6 carbons with alternating single and double bonds. Each carbon has 3 groups attached, and so it's trigonal planar with bond angles of 120 degrees. So this is flat, 2-dimensional, like a hockey puck, just totally flat, planar. Now, probably the most common aromatic compound in nature is graphite. So graphite comes from coal, which we dig up in the ground. And coal consists of layers of interconnected aromatic rings. So if you take this aromatic ring and you just connected a bunch of them next to each other like a honeycomb, and then you layered that honeycomb in sheets on top of each other, that's what graphite is. And so this is what we use inside of our pencils. People call it pencil lead, but that's not correct. It's graphite, actually. The name lead is kind of silly. That's another historical thing. When they first discovered graphite in the ground, they thought that it was lead. And then they later discovered, no, it's its own totally different compound, but the name had stuck. So they never actually used lead in pencils. It's always been graphite, but they called it lead because they used to think graphite was lead. So anyway, graphite is just a common example of an aromatic compound that you see in everyday life. So let's do a study check. Predict the shape and bond angles around each of the indicated carbons. So let's start with this one here on the left. This one looks like it has 3 groups attached to it. So if you have 3 groups, you are going to be trigonal planar. That's your shape, and the bond angle is 120 degrees. Now, this carbon here looks like he has 1, 2, 3, 4 groups attached. So if you have 4 groups, your shape is tetrahedral. Remember, tetra is Greek for 4, so 4 groups, tetrahedral. And the bond angle is 109 degrees. Now the last one, this carbon here, only has 2 groups attached. So if you only have 2 groups attached, you are a linear shape with 180-degree bond angles. So 3 groups, trigonal planar, 120. 4 groups, tetrahedral, 109. 2 groups, linear, 180. And it looks like we did it right. And let's do one more quick study check. Identify each compound as an alkane, alkene, alkyne, or aromatic. Let's start with this one on the left. Looking at this, I immediately noticed this carbon-carbon triple bond. And so anything that has a carbon-carbon triple bond is an alkyne with a Y. Oops. All right, this one here, I see this big 6-membered ring with 3 double bonds. That's definitely aromatic. This one here has a CC double bond. So remember, anything with a carbon-carbon double bond is called an alkene with an E. Oops. It's going to be an alkene. And then this one here, all single bonds, no double, no triple, no rings. This is an alkane. So alkyne, aromatic, alkene, and alkane. So once again, a hydrocarbon is anything that contains only carbon and hydrogen. An alkane is single bonds, alkene is double, alkyne is triple, and the aromatic is the 6-membered ring. Thanks for watching, and I'll see you in the next video.